I'll briefly demonstrate how to use a digital experiment that's measuring chemical equilibrium by measuring the equilibrium pressures in a constant volume system or the equilibrium volumes in a constant pressure system. And the reaction is gas phase decomposition. 1 mole goes to form 2 moles. So in a constant volume system, the moles increase and therefore the pressure increases. So we calculate equilibrium constants from these measurements. And if we make them over a range of temperatures, we can then calculate the heat reaction, entropy change reaction. So this digital experiment's on the LearnChemE website. Here's the link. Here's a snapshot of what the constant volume system looks like. We can change the temperature of equilibrium. We can change how much liquid we inject. So the idea is we inject liquid, it evaporates, reaction occurs, it goes to equilibrium. And we have to calculate from the pressure change. The pressure is going to change because 1 mole goes to 2 moles. More conversion, equilibrium conversion we have, the bigger the pressure change. Pressure is also going to change as we change the temperature from ideal gas law. We have to use both of these to determine from the pressure change what's the equilibrium conversion and therefore the equilibrium constant. So let's look at this simulation. Let's look at the constant volume case. We can turn on the heater and we could raise the temperature. We're going to do it at 35, so the system heats up. We can inject the N2O4, which is a liquid, room temperature and reasonable pressure. And the system is getting up to temperature, and then it'll get to its equilibrium pressure. And this equilibrium pressure, of course, is function temperature. So if I raise the temperature, I'm going to get more dissociation, more equilibrium conversion, and therefore the pressure is going to increase both because of the temperature increase and because the conversion, equilibrium conversion, increases. Now, the simulation has some brief directions. Most of the explanation is in this worksheet, which you can download, a PDF file, and it explains what measurements to make and what calculations to do. I'm showing here the constant volume system. We can also do a constant pressure measurement. So in this case, 1.3 bar. I could increase the temperature by first, of course, before the temperature goes, I have to turn on the heaters. I can inject N2O4, and then what's going to happen is the piston's going to move up until it reaches its equilibrium volume. And from that equilibrium volume and the ideal gas law, we can calculate what's the equilibrium conversion and therefore the equilibrium constant. Make these measurements of equilibrium constants over a range of temperatures, we can calculate the heat of reaction.